Humans have been able to use electricity since about 1800. First, there were chemical ways to generate electricity, and those were batteries. When that was discovered, it opened up a world of possibilities. So for that, you need chemicals. Like in the Duracell, there's zinc, sodium hydroxide, and some manganese dioxide. That makes electricity. Then, in the 1820s and 30s, humans discovered there's another way to make electricity, to make electrons move, and it's mechanical. Humans discovered that if you took a magnet and you moved it near some wire, then you could make electrons move. You could make electricity. So here I'll demonstrate that. This you know is an electrical measuring device. This is just a coil of wire here. So now you can see it's reading 0 electricity. But if I take this powerful magnet and I move it, you can see I start getting readings on the meter. But I do have to keep moving the magnet. If I stop, it goes to 0. So this discovery that if you move a magnet near wire, you make electricity, opened up, again, a world of possibilities. Clearly this is going to be tiring. If I want to keep moving the magnet, I am going to get sore. So then humans said, well, how can we move the magnet without having a person just kind of wiggle the magnet? And that's where generators were invented. And the first and obvious thing is, let's put this on a wheel. Let's put the magnet on a wheel and spin the wheel. Humans are really good at spinning wheels. That can make electricity. You can kind of see I'm doing it right here. Here's another electricity measuring device. It's called an oscilloscope. Oscilloscope. These little spikes here, those are called noise or random glitches. But here's my coil of wire and here's my magnet. And now if I start wiggling here, you'll see there are waves that occur in the signal on the oscilloscope, and those waves are waves of electricity. So in modern times, the generation of electricity is all about turning a wheel. If you turn a magnet, if you spin a magnet next to coils of wire, you'll make electricity, waves of electricity really. And that's what flows through the wall sockets in your house. So you need to be able to turn a wheel. This can be done with wind power. Those are the windmills that you see when you go to Palm Springs. It can be done with water power. There's the big dam on the Colorado River, Hoover Dam, that makes a lot of electricity. It can also be done by burning things and having a generator, like a diesel generator or a gasoline generator. And the big power plants turn really big wheels by burning fuels and making steam and sending that through a turbine. That's what the next section of this video will show you.
In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth.
Because of the laws of thermodynamics, all our electricity starts as some other kind of energy, which means all our ways to generate electricity are just fancy ways of converting one type of energy to another. And in most cases, the type of energy being converted to electricity is heat. Take a look at any of the various pie charts showing the breakdown of global energy production. You'll see that the vast majority of methods we use to generate power are essentially just different ways of getting water really hot. Many thermal power plants, as they're called, use fossil fuels like coal or natural gas in a furnace to generate steam. These type of plants have the obvious disadvantage of producing tremendous amounts of carbon dioxide as a byproduct, a greenhouse gas that's largely responsible for the ongoing rise in the average temperature of the Earth's climate, also known as global warming.
Thermal power plants generate electricity by converting heat into electricity, essentially by burning a fuel. One example of this is a nuclear power plant. Nuclear power plants use reactors' heat to turn water into steam. The steam is then sent through a turbine, which, as we've already learned, generates movement of a generator, which in turn generates electricity. A coal power plant works in much the same way. But instead of a nuclear reactor heating water to make steam, the heat from the burning coal powers a steam turbine.
Thermal power stations are pretty much all the same. Once the steam is created, it passes through a turbine, which converts thermal energy into rotational energy. The shaft of the turbine is coupled to a rotor, that's the part that rotates of an AC generator, that spins a set of magnets. The stator, that's the part that's stationary, has a set of coils of wire called windings. As the magnets on the rotor pass each winding, they generate a voltage across each coil.
Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states.